Good morning. Here's our daily lame joke with the Earth and the Moon dancing and the real reason for earthquakes. Today is this kind of officially marks the end of math for sixth grade. So we're going to work on um, some science today, and science uh, has taken a back seat to some of this other stuff this year, and so I feel like we've missed out on some things. We're going to talk about Earth's layers, and then you're going to do a little presentation for us. Sorry, that's probably a word that some people might fear. You're going to do a project, not necessarily a presentation, but you can do it that way if you want. So let me walk you through the Earth's layers real quick, and then I'll tell you what the assignment is. Um, you're going to follow a rubric, and here it is. It seems like it's pretty clustered there, but remember, if you want an A, you just only look at the four, and those are the criteria that you follow. We'll look at that a little more in depth at the end here. So the Earth is made up of different layers, and this is the anatomy of the Earth in a fancy little graphic here, where they've skinned it apart and pulled it out like a pineapple, and it's made up of these four main layers. There's the inner core, the core, the mantle, and the crust. And each one of those have a different composition, a different makeup. Some of them are solid, some of them are liquidy, and of course you know about the crust because that's where you live. But there's a significant mass to the Earth that we don't know anything about, and that's what I want you to do a little research on today. Is look up the layers of the inside of the Earth and the outside of the Earth. And here's a very basic view of the mantle, the outer core, and the inner core. There's actually some graphics that you'll find that talk about the mantle being different layers as well, or even the core being separate layers. But you don't have to worry about that. We want sixth grade level basic uh, geology on how the Earth works and what it's made up of. So here's another picture of it. Now this is breaking it up a little bit more, and they've identified the lithosphere and the asthenosphere. And if you're doing a little research on that, you can look that up. But I like this picture because it talks a little bit about the crust in two different forms. You've got the oceanic crust, which is the crust under the ocean, and the continental crust. And a lot of the times they're made of the exact same thing. But as you can imagine, what decomposes and erodes and changes on dry land is a lot different than what would happen at the bottom of an ocean. And so the sedimentary uh, makeup of the bottom is completely different in a lot of different places. But of course, the minerals that are on the earth, um, on the dry land part, on the continental crust, is also the minerals in the ocean. So there's some obvious similarities, but then there's differences as well, including like the fossil record, which we don't get to talk about much this year, but we did have the guy from Fort Hays come and talk about that a little bit. This is a very detailed graphic of it that when I was looking for pictures, I found this one. I like it. It talks about how you can have a really thin crust or a continental crust or the oceanic crust. These aren't, there's going to be a lot of pictures like pizza, but so that's probably some images that you'll think of. The sphere and the breaking apart of it into slices makes it look like pie or pizza slices. Um, there's always a question when we talk about this in class: is has man ever drilled through the continental crust or through the crust? And no, all of the oil that we know of, all of the reserves that people have drilled down into the ground looking for, exist within the crust, and the crust is several miles deep or kilometers. You'll see that soon, and we've never gotten the equipment to be able to get down that far. And so nobody's ever actually visually seen the mantle, and definitely not the outer core, the inner core. But there's a lot of science that goes into determining and deciding what it's made of. And so, because there's no visual proof, there's a lot of other evidence that they use to determine that it's viscous or liquidy center, and how hot the temperatures are inside. Nobody really knows for sure until I guess they see it, but there's some pretty good evidence that supports the way it is. This is a student representation of the Earth's layers. This one's pretty good. They did a little three-dimensional twist on it on some construction paper. That's what I'm going to ask you to do with a little bit more going on. Same thing here. This is the Earth's crust, upper mantle, outer core, inner core, and then it's got the layers of the atmosphere. So that's what I'm wanting you to include as well. Here's another picture of the Earth. This doesn't have the Earth's layers on the inside, but it has the atmospheric layers: troposphere, stratosphere, mesosphere, thermosphere, and exosphere. And then it's got little pictures in each that represent what would be up at those levels. This is a hot air balloon, in case that's hard to see. So this is where airplanes normally fly. Not that they can't fly up here. That's probably not necessarily hot air. It's probably a gas-filled weather balloon is what that is. And then here's another very basic view of that. So if you're having trouble with your research online or on the internet, you can come back to this slideshow because I'll share it with you, and then you can have the rubric as well. I'll drop it into Google Classroom with the video. Layers of the atmosphere. You can get a little bit more detail. This is a different representation of it. They use a y-axis that includes the interval of 10 kilometers. You can see that the troposphere only exists within, or pretty close within, the first 10 kilometers, and that's where most of the things that we interact with in our atmosphere happen here. If you get up above here, you have to do things like pressurize your cabin, although you need to do that in the troposphere too, and you need oxygen. You'll run out of the elements that the human body needs to exist, and that's why it takes a spacecraft to get up through these layers of the atmosphere. Here's a super detailed version that shows some other things like charged particles and radiation. Or if you remember basic science from early on, radiation is it's basically like heat or light rays that come out, radiate out in rays from some other source, such as the sun. Visible light radiates from the sun. Well, all of those things do. So that's more detailed if you want to spend some time looking at that. It's kind of neat. This one here, this is a student drawn project for me. He's a senior this year, but he doesn't go to our school. Dawson Snyder drew this one, and when he did his research, he looked up the spheres, but then he included all of the transition parts of the atmospheres, like so there's troposphere and tropopause. One problem with what he did is he's got the Earth here, and then there's a gap between the crust and the breathable air, which is kind of strange. But I knew exactly what he was talking about. He was doing this as different layers. Here's the interior of the Earth, and he really broke it down into the different parts. Colored well. You know what's going on there. He's got pictures in every layer, graphics of some kind, and that's pretty good. Here's another one that was done. This is Avery Haskett. This is Emerson's older sister, and she did a three-dimensional model. You can see the little styrofoam ball there, and she cut a quarter of it out, which is not as easy as it looks. And then she used toothpicks and duct tape and paper to label the different parts of it. And then she used a piece of cardboard to do the atmosphere and pasted on a piece of paper and colored it up real nice. That's a neat, very good project right there. One thing she also had was, like, she had a little rhinoceros right here, a little figurine rhinoceros that represented the crust, and then she didn't know what to do on the inside here. I think later I suggested maybe she could do a rock, or I don't know what you do for a liquidy phase, but you have to follow the certain requirements on the poster. you can do this in poster form. You can do this electronically if you want to do a Google Draw, or you want to just create your image with a bunch of other images. If you want to do a slideshow, you are welcome to get creative. You don't have to do three-dimensional. The basic poster is all I'm looking for, but you do need to include 9 layers. That's on the required elements. The poster includes all required elements as well as additional information. So if you have all 9 layers, and you have um, your measurements, and you have labeled properly, and you have your graphics, which is down below, then you get full points here. Graphics originality. If you just copy one of the images that are on my slideshow, you'll get the points, but you won't get full points for that because there's no creativity to it. You didn't put any of your own work into it. You're basically just copying notes, which isn't very creative, and that doesn't enhance your learning experience. So you don't get as many points for that. Relevance, make sure that they relate to it. If you put a star in the troposphere, if you're in an airplane, you can see the stars, but the stars don't exist in the troposphere. Stars are way out in deep space, outer space, in what is called the exosphere. So make sure that you put those in the proper place. And the same with airplanes. You shouldn't have airplanes up in the exosphere because we don't have any airplanes that can travel out there. And we do have shuttles and spacecraft out in the exosphere. Not shuttles, but that's what you're looking for, is to make sure that each layer is represented by an image that relates to it. Attractiveness, as long as you're just not real sloppy and it doesn't look like you put this together in about 5 minutes, you get the full points there. Just the better you have, the more likely I'm to use it as an example later. I have in my classroom 5 or 6 more examples that I've saved over the years, but I grabbed these 2 because they were easy to show you on video. Grammar, that's basically spelling, because you're not writing sentences, although you're welcome to. If you would rather explain than write graphics and draw, then that's fine too. Use of your class time. You know what? If you've got this project turned in, then you've used your class time well, and we'll give you full points for there. Okay. Labels are pretty important. If I don't know what you're drawing or what you're showing, I got to be able to read it. And so don't forget that. And then the last thing, content accuracy. At least 7 accurate facts are displayed on the poster. So up above, I want you to have 9 layers, but I also want you to have some facts about the different layers of the poster. If you have any questions about this stuff, feel free to email me. This is a required lesson for your science grade, but if this doesn't get done within the school year, there's probably no penalty. But this was, I thought, kind of a fun, interesting way to finish out the year in science. And it's one of those content area or curricular areas that I'm supposed to teach you in 6th grade that we've missed out on. Okay? Again, email me with any questions or any math. If you're still doing math, don't worry about the fact that you're behind. I won't judge you. I will help you, because you and I have to work together to get that stuff done. All right? Happy Monday.